I am Ramakrishna Reddy. We are going to discuss about vector spaces. When is a space said to be a vector space? You know, every space will have elements in it. The elements here will be called as vectors. So, what are the basic properties these vectors should possess? What are the eligible operations we can perform in this space? Only two operations: vector addition and scalar multiplication. That's all. Only these two operations, right? What is the criteria? There are five for vector addition and three or four for scalar multiplication. Together, these nine, that's said to be the rules. If these properties are satisfied, then that space is called a vector space. Normally, we denote that vector space by capital V, and the elements in that space are denoted by small v. So V1, V2, V3 are the elements in that space, or in general, in a linear algebra sense, we call them as a vectors. So V is a vector space, V1, V2, Vn, and so on. Vn are the vectors in that space. These are the basic axioms we call, or in a general language, these are the rules uh, the element should satisfy. Right. The first five for the vector addition, and the next five for the scalar multiplication. Say, take two vectors in that space, u and v. Then u plus v, the resultant vector, say w, should also belong to that space. Meaning, it should be closed. The space should be closed. U plus v, if it also belongs to that vector space, that is, the vector space is closed under the addition, then we say that the space is closed under vector addition. And commutative property should hold. Either way you can add u plus v equal to v plus u. Then if they commute, then we say that they are commutative under the vector addition. Next, associative mean u plus v plus u equal to u plus v plus u. Order doesn't matter. You can add in either way you want according to your convenience. Associative law should hold. And identity should exist. Of course, additive identity we know it's zero, meaning not the number zero is a vector zero. U plus zero equal to 0 plus u equal to u. Then 0 is the additive identity. Then inverse should be there. No? Additive inverse. If u exists, then minus u should also exist. So that together, the vector addition, the resultant should be an identity. That is u plus of minus v, or either way you can add. Minus u plus u should be equal to 0. These five under a vector addition. Then under a scalar multiplication should be closed, meaning Cu should also mean, you stretch how much, it should stay in that space. Cu should also belongs to V. Then it should be distributive. C times u plus V equal to Cu plus Cv. I mean, stretching the combination is as good as stretching them independently. Distributive over addition. C plus D times U equal to Cu plus Vu. Right? That's what we say, distributivity of a scalar multiplication over addition. Then, compatibility of scalar multiplication with the multiplication. C times du equal to Cd times u. Either way you can stretch first with C times or D times. Either way you can do. Right. Order doesn't matter. Multiplicative identity should exist. 1 is the multiplicative identity. 1u should be equal to u. If all the 10 axioms are satisfied, then we say that it's a vector space. Example. Suppose V is a Rn, mean it's a vector consisting in an n-dimensional space of real numbers, all the components, real elements of real numbers. Then we can easily see that it forms a vector space, right? Just to check out, you take n equal to 2 for convenience. Then I've taken two. Then I've taken two vectors in that space, u and v, and I see that their combination u plus v equal to vector addition is a component-wise addition. Then it belongs to the space again, right? Cu is the same. It belongs to the space again. So we see that it forms a vector space. Similarly, you can see the set of all 3 by 2 matrices, they form a vector space. Polynomials, they form a vector space. You can verify yourself all these things, right? Else you can go through the slide. It's a pretty simple job you can do, right? Subspace. It's name specific part of that space. We call it a subspace. Subspace should contain 0 vector. And any vector u belongs to w, right? So u should also belong to that subspace. I mean, all the other properties should hold. Then it's called a vector space. Now, in linear algebra, we live in a vector space, and vector spaces are very important. Thank you.